For most of Earth's history, the ocean was almost completely empty. No fish, no shells, no eyes, no predators. Just a thin soup of microscopic life, drifting, dividing, going nowhere for 3 billion years. And then, in the space of 20 million years, almost every body plan that has ever existed on Earth appeared at once. Wings, claws, legs, armor, eyes, not gradually, all at once. Scientists call it the Cambrian explosion, and we still don't fully understand how it happened. To understand what the Cambrian explosion actually was, you need to understand what came before it, the Precambrian, 4 billion years of almost nothing. Life existed, but it was simple. Bacteria, algae, thin mats of cells clinging to the ocean floor. For 3 billion years, that was it. Then, around 600 million years ago, something shifted. The first multicellular organisms appeared, the ediacarans, soft, flat, strange, more like living carpets than animals. They had no mouths, no limbs, possibly no nervous systems, and then they vanished. What replaced them would change everything. Around 538 million years ago, geologically speaking, overnight, the fossil record explodes. Within 20 million years, nearly every major animal body plan that exists today had already appeared. Arthropods, mollusks, chordates, the group that would eventually become every vertebrate on Earth, including you. All of it, appearing in the same window of time. But what did these creatures actually look like? Not like anything alive today. Take Anomalocaris, the apex predator of the Cambrian seas. It could reach a meter in length, enormous by the standards of its time. It had compound eyes on stalks, capable of seeing in nearly every direction simultaneously. And it had 2 grasping appendages at the front of its head, flexible, spiny, designed to seize prey and drag it towards a circular, jaw-like mouth. There was nothing else like it on Earth. Then there was hallucigenia. When scientists first described it in the 1970s, they got it completely wrong. They had it upside down. What they thought were legs were actually spines on its back. What they thought was its head was actually its tail. It walked on paired claw-tipped legs with a row of rigid spines running along its spine for protection. It was unlike anything in the modern world. And opabinia, 5 eyes, a flexible nozzle where a mouth should be, a fan-shaped tail. When scientists presented the first reconstruction of opabinia at a scientific conference in 1972, the audience burst out laughing. So here's the question that matters. Why did this happen? Why, after 3 billion years of doing almost nothing, did life suddenly produce an explosion of complex forms in what amounts to the blink of an eye? Scientists have proposed several answers, and the truth is, it was probably all of them at once. First, oxygen. Complex animal life requires oxygen, and for most of Earth's history, there wasn't enough of it. But in the late Precambrian, oxygen levels in the oceans began to rise. Enough, perhaps, to power larger, more energy-hungry bodies. Second, phosphorus. Phosphorus is the raw material of life. It drives biological productivity. Around this time, geological activity, erosion, volcanic uplift flooded the oceans with phosphorus. More phosphorus meant more food. More food meant more complexity. Third, the arms race. Once one creature developed eyes, everything changed. Suddenly, you could be seen, which meant you needed armor, or speed, or camouflage, or a better weapon. Each adaptation triggered another. A biological arms race, spiraling upward in complexity with no obvious endpoint. And fourth, perhaps most fascinating, a genetic switch. Hidden inside the DNA of almost every animal on Earth is a set of master control genes called Hox genes. They control where limbs grow, where eyes form, how a body is organized. And the evidence suggests that these genes appeared or became flexible right at the start of the Cambrian. Once life had the toolkit to experiment, it experimented with everything. We're only halfway through the story, and the strangest part is still to come. If you're finding this as fascinating as we do, subscribe to Hidden Earth. We cover the stories that the textbooks leave out. How do we know any of this? Most soft-bodied creatures leave no trace. They rot. They disappear. The fossil record of the Cambrian should be almost blank. And yet, in 1909, a paleontologist named Charles Walcott was riding through the mountains of British Columbia in Canada. His horse stumbled on a loose rock. He looked down and found one of the most important fossil deposits in the history of science, the Burgess Shale, a deposit of fine mud, 500 million years old, that had captured the soft tissues of Cambrian life in extraordinary detail. Guts, muscles, eyes, even the last meal inside a predator's stomach. It was a snapshot of an alien world, preserved almost by accident. Over a century of excavation has revealed hundreds of species. Many of them bear no resemblance to any living animal, which raises an uncomfortable question. If evolution is a branching tree, with every living creature connected to a common ancestor, where do these creatures fit? Some of them don't. Their branches led nowhere. Dead ends. Experiments that life tried once and abandoned. But some of them led here. Buried in the Burgess Shale is a creature called Pikaia. Small, flat, resembling a worm. But Pikaia had something that almost nothing else in the Cambrian had. A notochord, a stiffening rod running the length of its body, the precursor to a spine. Pikaia is one of the earliest known members of the chordate lineage, the lineage that eventually produced fish, amphibians, reptiles, mammals, and you. Every vertebrate animal that has ever lived, every creature with a backbone, traces its ancestry back to something like Pikaia, swimming in a Cambrian sea. The Cambrian explosion didn't just create animals. It created the possibility of everything that came after. All of it, rooted in 20 million years of biological creativity, 500 million years ago. We think of evolution as slow, patient, gradual, and usually it is. But the Cambrian explosion is a reminder that life, given the right conditions, is capable of something extraordinary. It can reinvent itself completely in the blink of geological time. The creatures that swam those ancient seas would be unrecognizable to us today. But without them, without that moment of creative chaos 500 million years ago, none of us would be here at all. That is what the Cambrian explosion actually was. Not just an event in prehistory, the moment life decided what it wanted to be. Hidden Earth. The most remarkable life on Earth is hiding, and we're here to find it. If you want to know what happened next, what those Cambrian survivors became, subscribe. The next chapter is coming.